actually our Chennai chapter chairman, Mr. Vignesh Ramanan, to deliver the welcome address to the audience.
A very good afternoon, fellow Foundrymen. It gives me immense pleasure in welcoming you all to today's online webinar organized by the IIF Chennai chapter. Today's topic, improving process efficiencies with advanced tools, is highly relevant to the industry as it addresses key factors impacting the production of quality castings. This discussion will undoubtedly empower foundries to elevate their standards and processes. We are privileged to have with us today Mr. Vivek Paul, Solutions Manager, Foundry Melt Shop, Foseco India Limited. He is a young professional and he represents a company which is renowned for its quality and standards. This marks our 6th webinar for the year out of 45 programs conducted so far by the chapter. We invite you all to engage actively, absorb the insights shared, and make the most out of today's opportunity. Once again, a warm welcome to everyone. Let's look forward to an enriching session. Thank you.
Thank you, Mr. Vignesh. Now I request actually our chapter chairman, vice chairman, Mr. P. Sendil Kumar, to introduce the speaker to the audience.
Good afternoon, fellow Foundrymen. Raj, hope I am audible. Raj?
Yes, sir. Yes, sir.
Yeah. Good afternoon, fellow Foundrymen. Welcome you once again for this webinar. Today's speaker, Mr. Vivek Paul, is a solution manager, Foundry Multi-Shop, Foseco India Limited. He has done his BE Metallurgy in 2005. He's got totally about 19 years of experience. And in this 4.5 years, he worked as an iron foundryman. And he has held various positions in Foseco India Limited. He has joined as an application engineer at Foseco, worked in Initech project, one of the Foseco's patented process for ductile iron and production, and a solution manager for ferrous metal treatment, dealing with products like inoculant, ferrosilicon, alloys, furnace, and ladle scavenging processes for iron and steel, and solution manager for Foundry Melt Shop, dealing with advanced refractory products for iron and steel, flow control products for iron and steel, and products in ferrous metal treatment. So Vivek Paul, the floor is yours.
Thank you, sir, for very brief introduction. And I'm very thankful to IIF Chennai chapter for giving me opportunity to share my experience with all of you. Hope my voice is audible.
Yeah, you're audible, sir.
Yes, sir. Yes, sir.
I'm just sharing the screen.
Yeah, screen is visible, sir. Kindly go into presentation mode.
Now, okay?
Yeah, now it's fine, sir.
Thank you. So, as already introduced, today's topic is improving process efficiencies with advanced tools. And the flow of presentation would go like this. Like we will start with what are the different challenges that we foundrymen and particularly ferrous foundries are facing, and how these challenges are aligned with the global trends. And then to meet these challenging and demanding requirements by customers, how Foseco, its products and offering would help to overcome those challenges. And at the end, we will take question and answer session. So when it comes to foundry, we all know that foundry makes casting, but it sells properties and dimensions. So when it comes to properties, we are talking about microstructural and mechanical properties, and which are coming from metallurgy. And we know that any variation in casting is directly related to the its metallurgy. So that's why to get consistent metallurgical and mechanical properties, it always challenging. And we need to design a robust process to meet consistent properties. As far as dimensions are concerned, core like mold and core from pattern side, they are taking care, and we don't see much variation in as far as dimensions are concerned. So, though foundry makes castings, customers are buying these dimensions and properties, and that's why this statement is made here. And when we talk about the overall challenges that foundries are facing, uh, for example, producing castings with consistent metallurgical and mechanical properties, Then improving casting lead time, particularly this is applicable to steel foundries, where because of the heavy rework, casting lead time actually always goes beyond the target date in weeks or sometimes in months also. Overall, improving profitability of a foundry by reducing rejections, improving productivity. So this has been always a challenge. Then again, emerging like even in Indian foundries also now very much concerned about operator safety, and they're also facing challenges to provide safety work environment to the workmen. And connecting to this is environmental concerns. Like now everybody is talking about carbon footprints and its impact on environment, and that is another challenge that foundries are facing. So in nutshell, to become preferred supplier in a global market is what every foundry's ambition, and that's why like to sustain in global market is a big challenge. And when we try to align these challenges with global trends, we we can say that what are the global trends in ferrous foundries, that automation and digitalization, wherein like now many foundries are going for IoT enabled devices, like Internet of the Things enabled devices, and so that they can connect the devices with other devices so that better process control can be implemented in the foundry. Similarly, robotic automation, 3D printing, these are some of the global trends in automation and digitalization. Same way, like sustainability and environmental concerns, where energy efficiency, recycling, carbon neutrality, these are some of the trends like that we are seeing in at global marketplace. Material innovation. We all know like now like casting grades are shifting. Uh, they're going for like high performance alloys or lightweight materials. For example, means now gray iron is shifting to CG iron because of good benefits of CG iron over gray iron. Forging component shifting to SG iron, and SG iron are now shifting to higher grades, SSF grades or ADI grades. So these are material innovations which are now in trend, and our foundries needs to cope up with these emerging needs of the customer. Then getting skilled manpower is another challenge, and we all know that because of the IT field, uh, good metallurgists or the skill working people who means skill people who wants to work with foundries are now getting diminishing. So that's why automation is another part. Like we should not depend more on labors or skill manpowers, but still at means somewhere or for some operations we need skill manpowers, and and globally shortage of skilled manpower is what we see. And so to meet all these challenging demands, how Foseco can help, that is what we in upcoming slides we will discuss. So when it comes to steel foundries, some common defects we face like cracks, non-metallic inclusions, poor surface finish, and higher lead times because of the heavy rework. And in connection to that, heavy consumption of electrodes, which also lead to higher cost. So these are some uh, some challenges in steel foundries. So for that, Foseco has come up with very advanced technology, which is known as rotoclean process. And you can see in the video during tapping, it is for steel foundry, and during tapping you can see a lot of air is also introduced with metal, and because of the air, we inclusions, bimetallic films are developed in the metal. And this operation we cannot avoid. Like we cannot tap the metal in under vacuum or something like that to avoid air entrapment or introduction of air. That's why this we cannot avoid, and therefore the defect associated because of this operation also are coming in the casting. However, there are some processes which are helping to reduce like inclusion. For example, in steel, argon purging is one of the solutions, but those have some limitations, and that's why advanced processes are required to so that effectively we can remove the inclusions and bimetallic films. Here, in the this is the animation video where you can see this blue is metal and brown is air. So air to metal ratio during tapping from furnace to ladle, you can see a lot of air is getting entrapped in the metal, and which is creating inclusions and bimetallic films, which which are actually not not good for casting because all those problems what we discussed, like non-metallic inclusions, poor surface finish, then inclusions are crack initiators, and because of that, casting soundness will get compromised. All these defects are coming if we don't if we're not able to remove the inclusions properly. That's why Foseco has come up with advanced technology called rotoclean, wherein you can see in the picture there is a rotor which is carbon bonded alumina rotor which goes inside the ladle and it rotates. And because of the stirring action, the temperature inside the ladle becomes homogenized. And at the same time, through rotor, we are purging or passing argon gas. And argon gas actually creates the fine curtain of bubbles. And these bubbles are lifting small inclusions from metal, and thus it helps to make the metal clean. So you can see the benefits. For example, before and after, what are the, like you can see the temperature variation near stopper of the ladle. You can see there is low temperature, and sometimes because of low temperatures, stopper could not get open, and maybe it breaks, and that is very unpleasant event and may lead to safety incidences also. Because of this system, we we are stirring the rotor, and it actually makes the temperature homogenized. You can see at after rotation, after treatment, you can see at any point in ladle, temperature is very much similar. Also, during stirring action, you can see here the fine curtain of argon bubbles is getting created, and which are lifting the inclusions and bifilms. And because of the homogenization of temperature and removal of inclusions, we can able to pour this metal at low temperature. And because of low temperature, we can minimize shrinkage and porosity defects in the casting. And also the overall mechanical properties, surface, surface finish will improve. And overall means if we achieve this, that means automatically casting lead time, casting rework will get reduced. That is one part, means we are taking metal from furnace, and now second part is we are pouring from ladle to mold, and you can see the difference. There are two, means we are talking about bottom pouring ladders using steel foundries. So conventionally, you can see on the left side, conventional bottom pouring, and the air which is getting along with the metal, and how much turbulence and air reoxidation is taking place. Whereas when we pour the metal with the help of shroud, you can see there is no air entrapment, and because of that, there is no reoxidation. That means no reoxidation means there is no chance to create inclusions and pipings during pouring operation. So tapping related we are taking care, but during pouring we also need some solution, and the solution is shroud. And how shroud look like this. It is actually a sophisticated pouring system for steel castings, and i- you can see the schematic. It has one shroud, and then choke area, diverter, and through diverter the runner bars are divided. So it is part of the gating system, and through shroud we are making gating system pressurized. Uh, Unlike in conventional method, it is non-pressurized. Okay, so Holotech shroud is extended technology of rotoclean process wherein it helps to avoid reoxidation losses during pouring. And the benefit, no air entrapment, no reoxidation. So it minimizes or eliminates inclusions and reduces the casting rework time. So combination of rotoclean and Holotech shroud will give very means high level of benefits in terms of reduction in casting rework and overall its surface finish improvement and casting soundness is also very high. However, when it comes to rotoclean, uh, at the moment we need ladle size minimum 4 metric ton, and below 4 metric ton we have not tried rotoclean process because as we go on lower side of metal volume, then there are like chances of temperature drop, which is not acceptable. That's why for rotoclean we need ladder size minimum 4 metric ton. However, for Holotech shroud, still we can use, but we need bottom pouring ladle necessarily, and there is no constraint for ladle size. For any ladle size, we can use Holotech shroud technology, like casting bunch weight ranging from 500 kg to like anything 10 tons or 15 tons, we can use Holotech shroud. Here it comes animation video to explain what is the rotoclean process and shroud pouring technology. You can see the MTU machine with rotor. Before rotor enters into the metal, it has to preheat it up to 900 to 1000 degrees Celsius so that no thermal shocks. Because of thermal shocks, rotor may get break. So this preheated rotor will enter into the metal. You can see it is bottom pour ladle with stopper and nozzle mechanism. Now rotor enters into the middle of the center of the ladle and start this stirring action starts with RPM like 260, 300, depend on like ladle size and other parameters. You can see the helical movement of argon gas which is passed through center bottom of the rotor, and because of this helical trajectory, it is uh, effectively removing biofilms and inclusions. At the same time, we are introducing calcium wire. It is pure calcium. It helps in inclusion modification, and the inclusions which are like alumina inclusions which are very detrimental, it modifies those inclusions with like unharmful inclusions. Because of the stirring effect, you can see temperature homogenization. Like at every point in ladle, you will get the same temperature, and there is no incidences like stopper stucking in the ladle because of the cold metal. So after this, the treatment time typically varies like 2 minutes to 6 minutes. Again, depend on ladle size and other parameters. After treatment, ladle will go to pouring, and here Holotech shroud is you can see pouring with holodeck shroud. The special nozzle of ladle will rest on the shroud. Shroud is accompanying with coupling set with springs, and the nozzle will rest on the shroud, and it ensures like it is airtight block and no air entrapment will happen. This is what the new technology for clean steel metal, rotoclean plus holodeck shroud. Now we can go to iron foundries, and what are the common casting defects we face? It is mostly related to microstructure, then microporosity, linkage, and machinability. So in microstructure for HGRN, lower nodule count or poor nodularity, these are some common defects. And in case of gray iron, not getting predominantly A-type graphite is what the challenge. And we are getting like D, E, sometimes B. Then carbides also, where it is gray or Ag, getting carbides in casting is also uh, one of the defects. With respect to porosity or shrinkage, in as cast condition as well as after machining, uh, we are getting this type of defects. And after machining means it is more severe because of it is coming with added machining cost as well as foundry cost. That's why cost wise as well as overall time consumed is also more. Means to when we face this defect, already we have lost some days, and uh, casting is rejected. Machinability, poor machinability related to like carbides, and variation in machinability, like some castings, uh, for some casting tool life, machine tool life is good. For some castings, it is not like that. So this variation, which is actually related to the properties and the metallurgy during casting process. So overall casting quality is depend on base metal and final means base iron as well as final iron. Base iron means at furnace level, which is like what type of charge mix we are using, in what sequence we are using the charge mix. Like when should we add carbon, or when we should add pig iron. Means that sequence is also very much important. So it comes under melting practices. After getting desired tapping temperature, still we are holding the furnace, then that is also not good, which is actually deteriorating metal quality. Means it kills the nucleation level, and we face other defects like because of the low nucleation level, we may end up with chilling tendency as well as porosity. So that's why and whatever bad metal quality we are getting in the base iron at the furnace, that is getting transferred to the up to the casting, like through metal transfer. That's why ensuring consistent good quality at furnace level is very important, and that is derived by melting practices, and for during metal transfer and pouring, inoculation practices playing important role. Also, it is very important to understand that there is no magical inoculation exist. Means whatever means if you are not following good practices in melting, and by adding some inoculant, if we are expecting by all metal variation will go away, so that will not happen. So inoculation plays important role, but up to certain limit, and that's why we need to follow basic disciplines in melting to achieve consistent metallurgical and mechanical properties. So this is one of the advanced tool. Now many foundries are adopting this technology, which is called as thermal analysis. And
ಓಕೆ, ನಿಮ್ಮ ಹತ್ರ ಒಂದು ಪೇಪರ್ ಸಿಗ್ನೇಚರ್ ಹಾಕ್ಸೋದ ಕೇಳಿದ್ದೀನಿ. ಹೆಲ್ಮೆಟ್ ಕೊಟ್ಟಿರ್ತೀವಿ, ನಾವು ಹಾಕೊಂಡಿಲ್ಲ ಅಂತ. ಸಿಗ್ನೇಚರ್ ಹಾಕಿ ಕೊಡ್ರಿ. ಏನಾರು
so thermal analysis tool is now means many progressive foundries are they are using it, and they actually they know the benefits of this type of tools. And Foseco also have this thermal analysis tool, wherein the key benefits, it is very user friendly tool. Like on screen you can through different means we will get different thermal parameters, and like if that thermal parameter is not as per the specification, then it will turn to red, and unless we correct it, we should not tap the metal for pouring. And this device we can means at a time we can take 4 samples. We generally put this device means it is actually wireless, means 2 channels we can install at pouring section and 2 channels at melting section, so that at a time we can compare metal quality at furnace level, and when this metal is transferred to for pouring, then after inoculation addition, how much improvement in metal quality we have achieved. So all these readings we can check, and accordingly we can optimize the additions of inoculant as well as ferrosilicon magnesium alloys. So this device we should use for regular production, and uh, like maybe for after certain period of time, Foundryman can get to know like for what parameters I should maintain, like what charge mix and other parameters. And this tool is actually helping for like what should be the parameters for consistent for getting consistent quality, because you know that like 2 cast irons with same chemical composition, their outcome, their microstructure, mechanical properties may differ, though the chemical composition is same. Why? Because of this, because chemical composition, which spectrometer tells us that spectrometer they have no capability to understand the metal nucleation level. It will show how much carbon and silicon, but what is the metal nucleation level, spectrometer cannot tell us. And for that, for same chemical composition, nucleation level may vary because of the different melting practices. And therefore, we need thermal analysis tool to analyze what is happening to my melt when I like superheat the metal, or when I change the charging sequence or charge mix, like instead of uh, returns, if I use more boring scrap, then what will happen to the metal quality? All these uh, variations would lead to metal quality, and thermal analysis will help us to understand that quality. Same like identical shapes or same geometry casting, also their solidification pattern will also affect because of the metal quality. And that's why ultimately the variation in terms of microstructure, in terms of mechanical properties, is associated with metal nucleation level, means charge mix, chemistry, and melting practice. Combination of these three will will uh, will tell us the metal quality, and thermal analysis has capability to analyze that metal quality. And if that metal quality varies, our casting properties will also vary. And that's why first we need to know what is variation, and then only we can correct it. So maybe majority of us are aware about this type of like CE meter. Are the many foundries they are using CE meter, so something like that. Uh, the cups are installed on the stand, and we pour the liquid metal, and inside the cup there is thermocouple, which actually uh, tell us what are the different thermal parameters and their readings. We need to interpret those results to understand metal quality. This is the graph which thermal analysis shows. Here are some thermal parameters. For example, TE minimum, eutectic minimum temperature, liquidus temperature, eutectic reaction starting temperature, eutectic reaction maximum temperature for this. So this blue line is temperature versus time. It is cooling curve, and red is cooling rate, derivative of this blue line. So these curves are is as a foundryman, maybe it is we don't need to understand this curve really in real sense, but we need to understand these parameters like T minimum, T solidus. These are some important parameters, and those are indicating the metal overall metal quality. And uh, is we don't need to go in more deeper to understand what these lines or what is the curve and all. Or only we need to understand the important thermal parameters. So this curve gives us information. Curves or the thermal parameters gives information about nucleation growth, graphite expansion, graphite shapes, thermal conductivity, and important point, it is not replacement of spectrometer. Spectrometer is having different function, and that we should continue. But to understand metal nucleation level, its quality, we need thermal analysis. Now, once we are able to measure the metal quality, then we can, there are various ways and means to improve that metal quality if it needs improvement. So after measurement, next action comes how we can improve. So one of the important product is inoculation or inoculants. And like what is inoculant? It is ferrosilicon based material with doping of some special elements like barium, zirconium, strontium. Depend on like casting grades and casting geometry, we select different type of inoculants. But the main role is they are creating more places for carbon atoms precipitate. Like effective inoculation means effective graphite precipitation. So it increases nodule count in HG iron. It increases eutectic cell count in case of gray iron. Overall, like it reduces the chilling tendency and makes uniform microstructure. Like in case of gray, uniform, predominantly A-type graphite. And uh, the effect of inoculation reduces uh, chill, chilling tendency of metal by promoting graphite precipitation. Then, irrespective of various section thicknesses in a casting, good inoculant, for example, in case of head and block type casting, where there is various sections, section thicknesses, varying from say 8 mm to 25-30 mm. So, giving similar mechanical properties at various sections, some inoculations are very much helpful. And once we get good or uniform microstructure, then automatically we get mechanical properties, and overall machinability is also improves. So this is what effect of inoculants. Again, very basic information on inoculant. Maybe we all know about this. What if we not inoculated casting properly? Means, for example, in case of gray iron, you can see gray iron with proper inoculation, and the other picture is without proper inoculation. You can see the microstructure difference. Like we are not getting A type; it is mostly D and E, which is carbides. Same way in case of HGRN, you can see without proper inoculation, nodule count also affected very much, and carbides we can see. So because of this microstructure, you can see the mechanical properties are also affected. Means if microstructure is not good, then mechanical properties will also affect. That's why inoculation plays very important role. Same way, in thermal analysis, we can correlate this with thermal analysis and with ion carbon diagram. This picture is one section from ion carbon diagram. We know this ion carbon diagram is like dual phase diagram where this dotted line is graphitic line and thick line is carbonic line. And our casting should always solidify in between these two lines, not above this line, not below carbonic line. Below carbonic line, all casting will solidify as carbides only, and above this graphitic line, we will get in case of gray iron, we will get pitch type graphite, or in case of AG, exploded graphite. So both both are not good, and we need to always ensure that casting is getting solidified uh, between like below graphitic line and above carbonic line. And inoculation actually helps in this way, because inoculation which has silicon is actually creating more gap between these two lines, and creating more gap means this line actually in thermal analysis indicates TE minimum temperature detecting minimum. So with potent inoculants and good melting practices, we can see the eutectic minimum temperature line is on higher side, like the temperature is on higher side, and the carbide formers, which if they are if these are there in the metal, manganese, chromium, moly, then we know we will end up with carbides, because these elements are closing means they are closing the gap between two lines, and they are not allowing casting to solidify above carbonic line. So that's why inoculation plays important role for minimizing or eliminating chilling tendency and microporosity. So inoculation is a product, but what if a good product is not applied in the right way? And that's why Foseco has come with application of inoculant, and this is particularly metal string inoculation, which is like 0.2 to 0.7, and which we used to apply at last last stage, like just before mold filling. And the reason behind it, metallurgically, it is important that we should miss about inoculation application. We should always remember that later is better and lesser is better. Later means what? As late as possible. If we could add inoculant, then that is effective. If we add inoculant just like in ladle during metal transfer, then that ladle will take some time uh, for pouring because of the travel time and all. And again, we need to add to cover up the fade time and its effect. We need to add more inoculant. More inoculation means actually we are adding impurities. It, it creates inclusions. That's why inoculation should be as less as possible, like optimum addition, and as late as possible. And the machine like this MSI 901, which is IoT enabled, this is new version of inoculation machine, which is helping to achieve this optimum addition rate at later stage. So, and we can link this device with pouring machine, molding machine, and also spectrometer, so that since it is IoT enabled, and we can get good benefit out of this technology. And this is what MSI machine comprises: control unit, hot box, hopper with cabling set, and it has to install near to press for unheated tundish, or even like that fixed means Fox machine, which are like mounting on rail. So there also this machine can be used. So it MSI machine is designed on the premise that inoculation is an engineering operation. So a consistent and robust inoculant dispensing system, which ensures every mold is getting inoculated the way we want, the way we set the addition rate, application rate, exactly, very accurately. It will doses the inoculant with that accuracy, and we can record real time data, like how much inoculation we have set, how much it has actually dispensed. So from quality audit point of view, it is very important feature, and we can ensure that at least from inoculation side there is no variation. So maybe we can check on other parameters, and our work for troubleshooting becomes much easier, because we are eliminating important process variable. Then this was about steam inoculant, and now we can talk about the ladle inoculation part. So many foundries, they don't have sophisticated pouring machines, and they still pour manually. And again, that important concept from inoculant point of view, that as far as inoculants are concerned, we should use as possible, and as less as possible. So we have come up with a new inoculant, which we call as the concentrated inoculants, and with that we can use that concentrated version of inoculants at very low addition rate, like 50% low, or even 75% low. And we have mainly two types, barium and zirconium. And the concentrated versions, like lower addition rate, and overall then the storage is his addition requirement is less, then overall your storage requirement will also reduces, and it gives a good cost saving. And also from casting quality point of view, since we are using in less quantity or optimized quantity, the quality side means there will not be any chances of inclusions or unresolved material, like that will not come. These are actual trial results of concentrated inoculants in Indian Foundry. So we have conducted trial with ours regular zirconium versus concentrated zirconium inoculant, and with regular inoculant, addition rate was 0.22%, and with concentrated inoculant, the addition rate was nearly 50% less, 0.11%. We poured uh, like 14 casting with proper traceability mark on the casting, so that uh, we could find out the difference. And again, this wet chill test for base metal, then trial 1 with concentrated, trial 2 with regular inoculant. So the reduction in chill with 50% lesser addition gave the same results, slightly better, like close to 40% reduction in chill we got. And then other parameters like hardness, at cast after machining was also similar. Tensile was also very much similar. And microstructure, you can see each and on each condition, both means concentrated versus regular inoculant. So with less addition also, we are getting good microstructure, good mechanical properties. Okay. So apart from this, Foseco do have presence in refractory materials. Like in case of steel foundry, we have lining material, which is the neutral ramming mass for induction furnace. Then for spout application, we have plastic refractories, which are specially designed for spout and top application, so that during charging, because of the impact of charge, uh, the the spout and top area used to get damaged, and through that damages, through cracks, metal sometimes get penetrated, and which is not good. Like it will, if it reaches to coil, then safety incidents will happen. So that's why we have designed a special plastic refractory material for spout and capping application. That is applicable for steel as well as iron foundries for induction furnaces. Then for ladle lining, we have variety of range, uh, like in conventional castables, ultra low cement castable, or no cement castables. So all those uh, products are available, and we provide application support and no, other troubleshooting support. So yeah, this is last slide, and here I end my presentation. Thank you. Thank you for your attention, and any questions we can discuss.
Thank you, sir. If any questions, actually, you can ask Mr. Vivek Paul, actually.
Hope it was not too fast. Means, hope I was not too fast, and
No, sir, it was not very fast, actually. Uh,
okay.
audience, actually, do we have any questions for Mr. Vivek? Okay, if there's no questions, actually, I'll deliver the vote of thanks. Actually, first and foremost, I would express our sincere gratitude to Mr. Vivek Paul, Solution Manager, Foundry Mill Shop at Foseco India Limited, for sharing his expertise and valuable insights. We also extend our appreciation to all our participants for taking time to join us today, and your enthusiasm and engagement make these events truly meaningful. Let's continue to collaborate, innovate, and drive excellence in the foundry industry. We look forward actually to seeing you at our future events. Thank you. Thank you, Mr. Vivek.
Thank you, sir.
Thank you all.
Thank you all.